Welcome to this webinar about Geospatial Energy Mapper. I am Jim Kuiper from Argonne National Laboratory. I work in the Environmental Science Division. GEM is a public web-based mapping tool that's designed for energy infrastructure planning. Today we'll feature the new updates that have been made. GEM was launched in September 2022, but it's actually a redesigned, re-engineered, and rebranded version of the Energy Zones mapping tool, which was launched about 10 years earlier in 2012. The project is funded by the Department of Energy. The original Energy Zones mapping tool was funded by the American Recovery and Reinvestment Act through the Department of Energy Office of Electricity. And later in a reorganization, it transitioned to the Grid Deployment Office, Leadership and Funding. The URL is given there on the lower right, and the home page is shown on the graphic. So the main features of GEM include a large mapping library of geographic information system layers, and a few of those are depicted on the slide there. The library's scope focuses on data that's relevant for energy analysis, and the scope is really for that purpose. There's also a modeling library, and I'll get into that later, the difference between mapping and modeling data, but that library has 100 GIS layers in it. Those are used for the suitability capability, which is the next major feature. Suitability modeling is a widely used GIS operation where you take a series of input criteria, and this is done with cell-based or raster data, and you assign values that have to do with the suitability or cost of a certain intended focus of the model. And after you've assigned weights to the layers and settings within the layers, a composite computed for every cell from all those inputs, and the output is a map with the composite values in it that represent the summation of the process. I'll talk about the modeling in more detail later. At the lower left of the panel is a good shortcut for getting started, both for new users and for ones who have used the tool for a while. With a single click, you can populate the map with data for a certain topic. The layers that get loaded in the table of contents, which is on the right, represent most of the data for that particular topic, but not necessarily all of it. And we've toggled some of the layers on so they'll be viewable on the map, and others are just available to turn on if you want to look at them and work with them. So that's a quick way to get started. And today especially we'll be featuring the new report tool that's been added. It's there on the left panel called Analyze an Area or Corridor, and I'll be demonstrating that during the live demo. As I mentioned, GEM has a broad data scope, and its data library is pretty broad. GEM is unique in the amount of data that it provides in a public interface without any login or subscription. The original scope and the continued scope for energy resources are really any source of energy that is used to generate electrical power. So those listed there are the scope for that. And geographically, the original project focused on the eastern interconnection, which is the electrical grid east of the Rockies, which doesn't include much of Texas. But later, the tool was extended to include all the U.S. states and territories. The modeling capability at this time is only for the lower 48 states, but we are planning in the near future to extend it to include Alaska, Hawaii, and Puerto Rico. The mapping content is collected from these organizations that are depicted with logos. Along with the data itself, we collect the metadata from the sources and include it so you can see data sources and a lot of information about the data. And you can download most of the data content in GEM. That download capability is really intended only for convenience. If you're really working in depth with the data, we recommend that you go to the original data source, make sure you have the latest version. There may have other content that we didn't include in GEM, and just go to those sources if you need to work with those data at that level. Here's a snapshot of the data catalog. Right now, the mapping catalog has 234 layers in it, and the ones that are checked in blue there would be visible on the map. If you want to add something to the map, you just check that box on the left. If you click on the title of a layer, that panel on the right will populate for that one. And you can see that there's a publication date for the data, a short description, and the updated is the date that we last either updated GEM with the information or checked against the original source to make sure that our version in GEM is up to date. However, with a library of 234 layers, some of them are older, and our updates are prioritized by how close and how important the layer is to the scope and use of the tool, how often the data change, and our total budget that we have available for working on things. Also, at the bottom of that panel, you can see there's a metadata button and a download button. So those are your means of getting at the much more detailed metadata, which opens up in another tab or window in your browser when you click that. It's a PDF file. And if you click download, the data file will download to your download directory by default. So the data content has four major categories that are depicted in those background boxes. And one of the key ones is energy infrastructure. So we have quite a variety of data that represents different types of energy infrastructure, and four of those are featured there. The wind and photovoltaic solar databases are quite detailed and extensive and spatially accurate, so those are excellent data sets if you need information about those types of things. Power plant data is provided by the Energy Information Administration, which is part of the Department of Energy. That's a pretty fundamental layer. And then petroleum refineries is an example of another type of infrastructure that we have available for viewing and download in the tool. I had mentioned the energy resources earlier. Here is solar direct normal irradiance. That is the amount of solar energy per unit area throughout the US. And that includes not only the sun angle and the amount of time it's over the horizon, but the amount of cloud-free time. So the intensity of the total sunlight over a long period of a year. And that is generated and provided by the National Renewable Energy Laboratory. Down at the lower left, we have siting factors. So those are different types of information that influence whether an energy project would be viable or not in a particular location. Land cover can be pretty important and is a quick way to screen sites. So dense forest would probably not be as appropriate as vacant land, and that can be gleaned from a land cover layer. That one there is of Hawaii, and that was recently added. National monuments are pretty dynamic. They get announced through the Antiquities Act. They can be designated by Congress or the president, and often new ones are defined at the end of a president's term, or they might be adjusted, and depicted there is one of the most recent national monuments that was created. Protected areas database is important for siting, and there you're seeing a national park in the center there, not very compatible with utility scale energy project. The last category is reference information, and that's a little bit more miscellaneous, but things like boundaries and congressional districts being one example can be relevant to decision making about energy. And then others depict status or condition of certain things, and EV registrations is one that we have available just to show the rate of adoption of electric vehicles, at least based on their vehicle registration records throughout the US. Another major feature of GEM is the suitability modeling, and this gives you a little bit more idea of what it looks like. GEM is pretty unique in having these models, both the amount of siting factors, the fact that you can easily generate your own results, modify the models for yourself, download the results, and the pre-configured models for quite a large portfolio of different types of energy infrastructure. Depicted there is the utility scale photovoltaic solar PV model, and superimposed on it you can see the solar photovoltaic sites that exist, and really a pretty good correlation between the darker shades of higher suitability versus the locations where these plants are being built. On the right there is a shot of the dialogue related to it. At the right side are the factors, the siting factors that go into the model. If you open up those sections, it'll have suitability factors from 0 to 100 for each of those, and everything's adjustable. You can delete layers with that little minus sign on the right, and you can add layers to the model by picking them in the Add Layer section and design your own updates. Once you've made changes, you click Run Model at the lower right, and that will create a new version of the model that you can access and view for yourself. Here we have the natural gas combined cycle gas turbine model with its input layers. Each of these layers, these are the modeling layers. They're cell-based raster data. They're 250 meter resolution for the lower 48 states. So every 250 meters is one cell, and for flood zones, it has the location of FEMA flood zones and their likelihood of flooding. There's a whole series of categories, and you can assign suitability factors to those from 0 to 100. Each of the criteria going into the model is from a different layer. These are the ones that are configured in the default model for natural gas model. For each cell, that's what I'm trying to depict there with that square with the 73 in it. Each cell is coded with that suitability value. So for instance, if we have a stack of these 10 values, those all go into the model, and then their weights are taken into account, and a weighted geometric mean is used to compute the final result. Since the geometric mean is multiplied, if you give 0 suitability for any of the inputs, it'll be 0 in the output, because multiplying by 0 yields 0. So that's a good way to screen out areas that are fully unsuitable, and the rest will come out with a value in that same range of 0 to 100. Within the interface, on the left panel, you click Find Suitable Areas. Then the panel shifts to have this step-by-step dialog. So here, selected natural gas and the combined cycle gas turbine model within that group. And below that, it's got the default model settings, and you can open up those sections and look at the weights and the inputs. If you click Customize this model, you can see this stuff a little bit easier, but you can also modify it and run it for yourself if you want to make modifications. Another thing that happens when you pick the model, it adds the layer to the map. It's been pre-computed for you, so you don't have to run it, and you can just view it. But if you do make modifications, you have to run it, and then you'll get a custom version of it. So here's just an example of the model in the background superimposed with power stations and zoomed into one. So this is the Union Power Station in Arkansas, and it's in a high suitability area of the model, 94. So we found good agreement between the model results and the location of this particular plant. Modeling is somewhat of an art. You have to have siting factors that are meaningful for the particular thing you're trying to locate, and it can be an iterative process where you look at the results and say, well, that didn't really yield what I expected, or I can see that this layer isn't working for me, and then you can make adjustments and fine-tune it. On to the next feature, which is reporting, and that's just been released. I'll be talking more about that today, but here's 3 examples of some of the reports, just the top end of the report. These are generally many pages. And the way these work is that they use the content from the mapping database, but they look up information for the area that you specify. So typically you would sketch an area or a corridor on the map and then generate a report for that location, and the topics listed there have been released so far. The process of running one of these, you click Analyze an Area or Corridor on the left panel. You get this step-by-step where you can select a report and then define your area that you're interested in, or pick one of the ones that you've previously input. The buffer is optional. So typical use of a buffer is, say you have a proposed transmission line route that's linear and you want to see what's near it, not just in it. Then you could find a buffer around it, say 5 miles, and then the report will have added information for that region around the corridor. And that name appears as a subtitle in the report. So that's also optional. And you can see on the top right of the report, it's given there in this example. Once you click Run Report, the report dialog runs showing the progress. And these can take anywhere from seconds to few minutes to run, depending on how large your area is and how dense the data is that it's polling to try to pull things together. And then when it's done, the button's enabled. When you click that, the report opens in a separate window and you can print it if you like. Another feature is the file tool. That's been released for a while, and it's at the top right of the interface. There's a file button. So what this does is if you have your own GIS data, you can load it into the GEM mapping tool as a map overlay. It's a fairly simple depiction of the data. You pick a solid single color for it, so there isn't as much nuance to the data that's viewed on the map. But it's really useful for viewing information that isn't already in the GEM database. It supports shapefiles, KML, and GeoJSON formats, and importantly, the information that you load with this tool is only in your local browser memory. And if you quit that panel or quit out of your browser, you'll have to reload it. It's not preserved in any way or transmitted or loaded into GEM database. It's just a local viewing. And here the example is coming from National Hurricane Center data, Hurricane Helene forecast number 5. And I've loaded 4 different files that come from that storm forecast. The rest of the time I'll spend in a live demonstration of these things, and I'll be covering these topics. Here's the Geospatial Energy Mapper landing page, and I just want to point out a few elements of it. So there is an introductory video that gives you a quick tour of the interface and the capabilities of the system, so that can be helpful. We have a YouTube channel that we're starting to add training videos to and recording of this webinar, for example. And then this news section is where we will post about updates that we're making to the tool. So that's the most recent one, and if you click the More button, another page opens that has the list of all the different news items that have been added. When we send out newsletters, those go out to the subscription list, so if you're interested in those, you can input your email there. Also, I want to point out at the bottom there's a Contact Us, and you can use this gem@anl.gov email for any questions or comments or inquiries that you want to make about GEM. This Launch GEM button on the home page will open up the system in another tab. As I mentioned earlier, a great way to start is this section, the mapping themes, and it provides a single-click approach to getting started. So here I clicked electrical infrastructure, and it has populated the map with most frequently used data for electrical infrastructure that we have in the tool. However, there can, for some of these themes, sometimes it's just a sample of the main data layers, and you can find added content in the data library. Also, the selection of layers that are shown on the map is pre-selected, and you can toggle layers on and off by clicking that, and so that toggles them. The transparency of a layer can be adjusted with this slider, and then the minus button removes it from the table of contents. You can also drag and drop to change the drawing order, and that's the interface for navigating the table of contents. I'll also point out that if you click the title of the layer, another version of the panel in the catalog will show that I talked about earlier with the same information, including the metadata and the download button. You can access the layer catalog from this button on the left panel or this layers button on the right panel. And sometimes when you're using other tools, this one isn't available, but you can get at the catalog at any time with this button up at the top right. Here's the catalog. You can see at the lower left, there's 234 mapping layers. So this button here is filtering for only the mapping layers. And if I turn it off and switch to model input, you can see there's 101 model input layers. Another way to view those models, you can just add them directly to the map with the model output button. So typically we're working in the mapping library, and first one, and I pick some category filter. So now we're only showing the layers within the boundary category, and say we want to add congressional districts to the map. All right, so let's interact with the table of contents a little bit. We'll drag this below the others so you can see it better and make it transparent. And I'll just explore the map a little bit here. So zoom in, You can see there's some major transmission lines coming into Chicago from the southwest, and at the corner of these are these yellow dots. Well, those are nuclear power plants. So let's take a look at one of those and see where all that generation is coming from. I can click on features on the map to bring up this info box and can adjust it. Here we have the LaSalle generation station. The transmission line there was 345 kV. And since we have the congressional districts there in the background, it's also going to pick that for us and let us know which one we're in. I'll turn that off a second. By the way, if I click on features, it'll show that info box. If I click on the map, I can drag it around as a way to pan. And it wasn't maybe that evident, but I'm using the mouse wheel to zoom in and out. You also have this tool here. You can click zoom in and zoom out. And you can also double click to zoom in the map. And if you hit shift double click, then it'll zoom out. So a few ways to navigate there. At the lower left, we have a few choices for the Basemap. For one thing, I can turn it off entirely. And sometimes when you have a lot of data on the screen, the Basemap is just a distraction, so you can turn it off. There's also aerial photography and imagery. So here you can get a really good close look at that nuclear power plant and its cooling ponds around it and some of the other related infrastructure that are there. Let's go back to the layer catalog. And I just wanted to show you a little bit more navigation there and also some of the especially interesting data that we've had recently. This filter by keyword is not only the title of the layer, but it includes data sources and other related keywords. So let's try FEMA. And here we have two layers coming from the Federal Emergency Management Agency. And I'm going to add the National Risk Index. This is a pretty interesting data set, and certainly natural hazards are a consideration for siting infrastructure. So let me get the maps reset here a second. Zoom out a bit. And you can see here we have the National Risk Index composite score. So this is kind of the cumulative total risk. And this score not only includes the types of hazard and their frequency and severity, but also population density and property value. So this is kind of more of an insurance assessor's map. Which areas would have maybe expensive claims because of how frequently they might have some kind of natural disaster, as well as the value of property and the number of people there. So you can see some of that information in this info box, but there are many other variables in this data set if you download it. Here you can see all these different types of hazards are there, and we're just showing the risk index for those. We've added a modeling layer for this, so you can use that as something to consider for siting. And we're planning to add another one that concentrates more on risks to electrical infrastructure. So for that, we will be weighting different types of hazards according to how important they are for infrastructure reliability, and not taking into account property value or population density, which wouldn't be directly associated with the risk to that infrastructure. Another data set of interest I mentioned earlier was that national monuments. So you can start typing monuments, pick it here, and this we put together from several sources. National monuments change pretty frequently. They're designated by Congress or the president. Sometimes they transition to, say, a state park or something like that. And other times the boundary may be adjusted. One of the recent ones that was designated is here. This is the Chuckwalla National Monument. And so this should be a useful layer. Typically it's coming from several land agencies, and we just pulled together a few data sources to make this composite. Getting into the model input layers, I'll show you a couple interesting ones. So just to repeat, there's that National Risk Index score. So this version of the data in that raster format, this is generated from that other data, but now it's just a single score and it can be used in modeling. So that's available if you wanted to include that as a citing factor in a model. That's in the library. Another one of a lot of interest on AI data centers, one of their requirements is a lot of power. So we've added some layers related to power. And I'll show you the power plant megawatt capacity per square mile, which is the aggregate of all the power plants within a radius of 25 miles and their total generation. And we also have proximity to large power plants. Here we have proximity to power plants of a gigawatt or larger. So let's first look at the power plant capacity per square mile. It'll take a minute to draw here. You can see areas where pretty high concentration of power generation exists. And then here, data represents large power plants and their proximity. And if you were to click on it to look up a distance, so this particular place I picked is 135 kilometers from the nearest gigawatt-sized power plant. So that's just a few examples from the data library of things that we've recently added or that are especially interesting. And I think you'll find a lot of interesting data if you take a look at it. I'm just going to clear the table of contents by clicking these minus buttons here. So we can go on to another topic. And let's go back to electrical infrastructure as a baseline map. And for the reports, you click Analyze an Area or Corridor. And you can select among a whole variety of reports. So let's pick power plants. And I'm going to zoom in and draw an arbitrary area. I want to learn about the power plants in a certain region. So I click Download this list, and I say Draw a New Area. These two options won't show up until you have saved some of your own areas, and I've got a list of them saved myself. But let's draw a new one, and I'll just sketch something quick on the map. So you pick this option, click Draw Analysis Area, and just kind of sketch on the map. And remember, you can zoom in and out by rolling the mouse wheel if you want to change your view. And double-click to finish. Once you've done that, you can continue to work on the area. If you pick one of your original points, you can move it around and adjust it. And if you pick between them on the boundary, you can add a new shape point and adjust it. So you might want to just start with a simple area and then zoom in and refine it as a way to get your area input. When you're finished, you click Done, and you can give it a name. I think I already have one called My Area, so if you give it a name, it'll be saved. It's optional, so if you don't give it an area, you can still create a report quickly, but you don't need to save the area. If you want to have an area, a buffer added to your report, you can optionally specify that. I'll demonstrate that in a minute. And then this name will become a subtitle in your report. That's also optional. So now I click Run Report. And once it finishes, the View Report button will be populated. You click that button, it'll open up a new tab or window. And here's an example of the power plants report. So these reports typically start out with some general summary information and then more detail farther down. Here we can see the portfolio overall of the different generation sources in my area. And it's got a 3.4 gigawatts of generation in that particular area. There were no nuclear facilities in the area I picked. These two data sets are especially detailed and interesting for photovoltaic, solar, and wind facilities. And then as you continue, you'll get some more details. The power plant detail section has subtables based on the primary energy source. So we've got a battery energy storage location in Iowa and Marion. You can continue through and see all the different types of power plants with their capacities. Deeper level of detail on the photovoltaic and the wind turbine data will round out the report content. Okay, let's try another one. If we close this out, we can switch to a different report. Let's try protected areas. And I'm going to select an existing area from my list and then run this report. So this one features the protected areas database, which is a pretty large and detailed database. One thing I didn't mention, by the way, is the source. This link below will bring up that metadata, and you can use this to try to, so if you're not sure which layer in the mapping library was used for the data, you can find it out here and view that layer on the map if you like. So this includes protected areas. Conservation easements are legal agreements typically for open space and wildlife habitat. So we've got about 13 square miles in the area I analyzed, and there weren't any of these categories. Like before, there are detailed listings later in the report. That's a quick look at the protected areas report. As another use case, let's do a corridor. Maybe we want to connect these two locations with the new power line. Let's look at the jurisdictions report, and we're going to draw a new corridor, and just a simple one. This is similar to the areas where you click draw, and then you sketch it on the map, double click to finish, click done, and give it a name. And this time, well, first of all, it has a width to it. And if you zoom in, you can see that there's sort of a polygon around it. But we can adjust that width here. So say we want to make it 1,500 feet wide. That's where we do that. And that will be the area that's analyzed. But say we want to know what's near the corridor, we can give it, say, a 5-mile buffer, and that'll be included in the report as extra columns. So I'm going to run that. When that finishes, we click View Report. And this report lists all different types of jurisdictions that exist along that corridor. Within the corridor is this column. And for example, this Mahaska County is only in the buffer and not in the analysis area. So this gives the total area of that corridor overlaps in each county. Here are the cities that are, there are no cities within the area the corridor passes through, but within the buffer, these cities are near, and it's in this undetermined land management. So the layer being used here is federal land. This is essentially non-federal land of unknown type, and we have 2 congressional districts that are overlapped and no tribal areas. That's an example of learning something about your corridor using the report function. A trick to reset GEM entirely is to just reload the page, and that's going to clear the slate. Next, I'm going to do a quick demo of the File tool. I click File, and I have some shape files that I've already browsed to, so it's typically you would find it in your file system. And these are hurricane forecasts, like the one I mentioned earlier. Here's the forecast for Hurricane Helene Advisory 5. And I click Load, and I can give it a title, so that'll appear in my table of contents as the name, and I can pick a color for it, and if I have this box checked, it'll zoom to the location of that shapefile once I click Add. So here's our hurricane forecast, and I'm going to adjust the transparency of it. I can see the base map, and then I'm going to go back and add the track, which is in this file. It's just a line of the path of the storm, maybe just a black for that. So you can add GIS files that way to your map, and if you were to pick the base map, that allows you to view your local personal content with any of the content that's in GEM, whether it be modeling data or mapping data, model results, etc. I'm going to have a very cursory treatment of the models, and the material in the slides describes that a little bit more, but it would really take a full webinar to dig deep into the models. I'm just going to turn off a couple current layers and briefly talk about models. That is the Find Suitable Areas button, and first you would choose the technology you're interested in. Here, let's go back to the natural gas. So the second dialog, here it only has one, but it can have a group of choices. And once you pick that, it adds the default pre-computed version of the model to the map with its suitability score range. And I can inspect the input values in this panel if I like. A more convenient way to view those and a way with more capabilities, you click Customize this model. And this is the full model editing dialog. So here you can see the weights that were given, and for any layer you can open up its suitability factors, adjust those if you like with typing or arrows or sliders. And here it's saying 100% suitability if we're within a mile of a substation of at least 115 kV, and as you get farther away from substations, the suitability drops. These are set for all of these inputs. I'm just inspecting the model. If you want to customize the model, you can delete something that you want, take out of there. Let's take away some of the land protections and say we can add that risk index score and add that to the model. So that'll come in with its own preset settings, but you really need to inspect those to see if they make sense for the thing you're modeling. Here we're saying if there's really low risk, then high suitability, and as we get extremely high environmental risk, then we don't want to site projects there. So that allows us to take risk into account in our siting. You can change the name if you like, and you can type a description. Once you're finished, then you click Run Model, and it'll get queued up on the right. This one has a lot of layers in it, so it'll take a while to run, and I'm not going to wait for that to finish. But when it does finish, it'll add the model to the table of contents as a mapping layer, and you'll see it added down here. I've got a previous run already listed. I can add it to the map. It happens to be a natural gas model, but I didn't change the name to make that clear. I can download the result if I want to keep that GIS file, or I can remove it. And another important thing is after I've inspected and looked at the model and how it did, I can go back to that dialog. It only allows one model at a time, so it's not letting me open that dialog. But if I click that option, it'll show the settings that were used for that particular model, and I can modify them again and keep having iterative process till I'm satisfied with the results. That's enough about models for this webinar, but there's a lot more that you can do with it, and some modeling techniques that can really help understand the results of the model, why it computed a certain value in a certain location, as well as some ideas for refining it and deciding what input factors and those sorts of things. But I appreciate your attention and have a good day.